By the end of this video, you'll know how to find the internal volume of your Fusion 360 model. The goal of this tutorial is to save you time, frustration, and hopefully even some money by not wasting your filament. Now, I've seen many people 3D print something out only to find out that it's in the wrong size. So I'm going to show you guys a few tips and tricks to check both the internal volume and the overall volume of a model. Knowing the internal volume of your model can also be helpful if you're going to fill the model with another material. For example, if you 3D printed out something to be used as a mold, then you may want to know the internal volume in order to use the correct amount of resin or other desired material. Now, this tutorial's resource page can be found at productdesignonline.com/8. Once again, that's productdesignonline.com/8. For the first example, I'm going to show you how to fill the inside of an object, which will let us determine the internal volume. I'm going to use the whiskey bottle that I created in a previous tutorial. However, you can follow along with any model. First, I'm going to change the physical properties of the model so we can see the inside as we're working on it. I'm going to right-click on the whiskey bottle component, and then I'll select the physical material option. From here, I'll click on the glass folder to toggle open the available glass options. Then, I'll drag and drop the glass option on top of the model. Now that we can see through the inside of our bottle or whatever object you're working on, we're going to create a construction plane that we can reference with the boundary fill command. I'm going to use the offset construction plane. I'll activate the offset construction plane by selecting it from the toolbar or from the construct drop-down list. Once the offset plane is active, I'll select the bottom face of the bottle. If you're using another object, then you'll want to select the equivalent of the bottom face if you were to fill the object with water. For now, I'll simply drag the blue single directional arrow upwards, and once I have it positioned somewhere in the stem of the bottle, I will click the OK button. At this point, we're ready to use the boundary fill command. I'll select the Create drop-down list, and then I'll select the boundary fill command near the bottom of the list. Looking at the boundary fill dialog box, you'll see the first option we need to select is our tools. You can think of the tools as both the object to fill and the body, plane, or surface that represents the boundary or stopping point of the fill. In our case, we'll need to select the bottle as our first tool, as this is the body that we want to fill. Then, we'll need to select the construction plane that we just created as our stopping point or the boundary. After selecting both of our tools, you'll notice that I have two checkboxes that appear on the model. Now, these checkboxes represent the cells or areas that we can fill based on the selection of tools. So the number of checkboxes and the placement of the checkboxes will vary based on your tool selections. I'm going to first select the Select Cells option in the Boundary Fill dialog box. Then, before I do anything, I'm going to make sure that my whiskey bottle component is active. And I'll toggle open the Bodies folder so you can see what happens. I'll now select the checkbox for the bottom cell, as that's the area I want to fill with a liquid, in order to check its volume. I'm going to also double check that the operation is set to New Body. Real quick, I just want to point out that you can use the Boundary Fill tool in many other ways, such as cutting away from bodies. but I want the focus of this tutorial to be on how you can utilize it for checking the volume before 3D printing. So I'll have to make another video solely covering the boundary fill command. At this point, I'll click the OK button to see what happens. You'll notice in the bodies folder that there is now a second body just below the bottle body. I'll right-click on this newly created body, and once again, I'll select the physical properties option. This time, however, I'll find the water property, and I'll drag that over to the body in the Fusion 360 browser. Now, if your body is internal, such as this case, then you'll find it's much easier to drag the physical property to the object in the browser instead of the model in the canvas window. Before checking the volume, I'm going to rename the body that we just created with the boundary fill command. In the Fusion 360 browser, I'll click on the body once to select it, and then I'll click a second time, which opens up the input field. I'm simply going to type out the word liquid, and then I'll hit the Enter key on my keyboard to submit the name change. I'm also going to hide the construction plane so it's out of the way. I'll select the construction plane, and then I'll hit the keyboard shortcut letter V as in Victor for the view/hide command. You'll see that this hides the construction plane. Now, the great thing about the boundary fill command is that we can actually change our tool's position and the fill will update accordingly. I'm going to double click on the construction plane in the timeline down below. Then I'll simply drag the blue single directional arrow down until it's somewhere in the base of the bottle. Once I'm happy with the position of the plane, I'll click the OK button in the dialog box to see the results. You'll see that the liquid body updated accordingly. Now, to check the actual volume or mass of the liquid area, we'll need to right-click on the liquid body in the Fusion 360 browser, and then we'll need to select the Properties option. This will open up the Properties dialog box, in which you'll see a number of helpful values that can be a great resource before wasting the time and money on a 3D print. You'll see that you can check the mass of the body, the volume of the body, the density of the body, and you'll even see that if I toggle open the bounding box caret, that you can see the outer dimensions of the liquid body. At the very bottom of the dialog box, you'll have some details on the moment of inertia, as well as the ability to copy all of these data values to your clipboard so you can paste and save them in another program. Before I show you guys another example of this boundary fill command in use, I wanted to take a moment to let you know that I've finally launched a Patreon page. Some of you guys have asked me about Patreon for quite a while now, so I'm excited to finally launch my page where you can support the free Fusion 360 content that I make for as little as $1 a month. You can check out my Patreon page at patreon.com/product design online, where you'll be able to see the different levels of support. Now, I'll also put a link down below in the video description for your convenience. With that said, I promise that I'm not going to start asking for your support in every tutorial. However, if you have been enjoying my tutorials and feel that you've learned a lot, or that they've brought value to you in any way, then please support me on any level that you can. Let's now get back to another example of the boundary fill command. I wanted to point out that to use the boundary fill command, you don't have to necessarily have an object that has a completely solid bottom. I'm going to click on this second design tab that I have open, where you'll see a vent cover. With this example, I'd like to figure out the volume of this inner area. However, notice that the bottom has slots for the vent. Now, the trick to getting the boundary fill to work is to create some construction planes that we can then reference when using the boundary fill tool. I'll create another offset plane by selecting the Offset Plane button in the toolbar. Then I'll simply click the top surface of the extruded cylinder. At this point, I'll leave the offset at 0 and I'll click the OK button. I want to include the volume of the gaps, so we'll need to create the second offset plane on the bottom surface of this flange. I'll right-click in order to select Repeat Offset Plane. Then I'll select the bottom of the flange. Once again, I'll leave the offset distance to 0 millimeters and then I'll click the OK button. Before doing anything else, I'll make sure to activate the cover component by clicking the Activate button in the Fusion 360 browser. I'm going to then hit the keyboard shortcut letter S as in Sierra to activate the Shortcuts box. I'll start to type out the word boundary in order to quickly select the boundary fill option by hitting the Enter key on my keyboard, as that's the first result in the search box. For the tools of this boundary fill, I'll select the main body of the vent, and then we'll also need to select both construction planes. After all three tools are selected, I'll switch to the cell selector in the dialog box. From here, I can choose the checkbox in the middle or the bottom checkbox. And then I'll click the OK button to create a new body. If I now toggle open the component folder in the Fusion 360 browser, and then the body folder, you'll see that I can hide the main vent body to show the body that we just created with the boundary fill command. Now, the nice thing about this command is just how easy it is to create complex shapes. Take notice of how all the vent holes are created with just a few steps, and we can now check the volume. Once again, I'll right-click on the newly created body in order to select the Properties option. Here, you'll see the volume of the inside of this vent, if this is something that is helpful to check before you go to 3D print a part. In some scenarios, you may even want to check the volume of the entire object, not just the internal volume. To do this, I'll close out the Properties box. Then, I'll right-click on the top-level component in the Fusion 360 browser, which selects both the vent body and the internal boundary fill that we just created. I'll once again select the Properties option, where this time the Properties dialog gives you the mass and volume values for the entire model. If you made it to the end of this video, then let me know by commenting below any ideas that you have for 3D printing related tutorials. As always, I really appreciate you taking the time to watch this tutorial. If you've enjoyed this tutorial, please click that thumbs up icon and click on that playlist in the lower right hand corner to watch more 3D printing related Fusion 360 tutorials. To be part of the Product Design Online community, be sure to click that red subscribe button and click that little bell icon to be notified of more Fusion 360 tutorials.